Trigonometric identities. Cosecant x plus cotangent x whole square equals to secant x plus 1 divided by secant x minus 1. So write secant x here. Okay, so we can start with left side and see what happens, right? So basic strategy is to write them in terms of sine and cosine. So we'll start with left side. So left side is equal to, so we have cosecant x plus cot x whole square, right, on the left side. Now this could be simplified and we could write cosecant x as 1 over sine x plus cot x is cos x over sine x, right, whole square. So this could be written as, so we have sine x common denominators. Let me write sine x here, and the numerator becomes 1 plus cos x whole square. Correct? So what we are looking forward to is secant square x minus 1. So let's write, now let's open the bracket. This becomes square. Let me write this as first 1 plus cos x whole square divided by sine square x, right, since this was square. Now I can write sine square x as 1 minus cos square x, and then I have 1 plus cos x whole square in the numerator, correct? Now let's take it to this side. Let me just transfer this. I'm moving from here to this place, okay? I'm still working with the left side only, okay? So I'm not changing from left to right. I'm just moving this and continuing the process. So now 1 plus cos x whole square is in the numerator, and I've got 1 minus cos square x in the denominator. I can factor this out, right? 1 minus cos square x, and then I can write this as equal to, so I'm writing 1 plus cos x whole square in my numerator, and this can be written as 1 plus cos x times 1 minus sine x. Sorry, 1 plus cos x times 1 minus cos x. So we used a square, so we factored this out, right? So a square minus b square is a plus b times a minus b. That is what we used here, correct? Let me write here for simplicity. So I've used, this is a square minus b square, right? A square minus b square is equal to a plus b times a minus b, right? And here I used Pythagorean identity when I wrote sine square x as 1 minus cos square x, correct? So, you know, sine square x plus cos square x equals to 1. So sine square x can be written as 1 minus cos square x. So that is what I replace this sine square x with 1 minus cos square x, correct? Now if you look at it, then that cancels out, right? And therefore we are left with 1 plus cos x divided by 1 minus cos x. Correct? But still our identity is not proved, right? We need to find secant x, not in cos x terms, secant x. So let's do one thing. Let's factor out cos x and see what we get. So if I factor out cos x, I have to write 1 over cos x for 1, right? Plus 1. And the denominator, if I factor out cos x, I get cos x times 1 over cos x minus 1. Do you see? That is the trick. And now here, cos x and cos x cancel out, right? And what is 1 over cos x? 1 over cos x is secant x. So I get secant x plus 1 divided by secant x minus 1. So that is how my identity has been proven. I started with left side, and that is my right side, right? Now since left side is equals to right side, I see that the trigonometric identity is proven.